Determine the sum to infinity of the following series. Let us begin. So here we have a infinite series. So let's name it. So let's say this series is represented by S infinity, which means that we have sum up to infinite number of terms. We have 1 squared added to 2 squared times x added to 3 squared times x squared added to 4 squared times x cubed. So this keeps on continuing. Now this particular sum, this is not an arithmetic series because we do not have a common difference here. We can take any term in the sequence and subtract the previous term from it. The difference that we obtain is not going to stay fixed. It's going to vary. That's why it's not an arithmetic series. Also, it's not going to be a geometric series because there is no common ratio here. And it is also not an arithmetico-geometric series. However, so let's call it number 1. If we take x and multiply it to each terms of the sum as infinity, then we have 1 squared multiplied to x, that gives us 1 squared times x added to 2 squared times x multiplied to x, that gives us 2 squared x squared added to 3 squared x cubed, and this is going to continue. Let's perform a subtraction here. So we're going to name this as number 2. So when we do 1 minus 2, so we will get 1 minus x multiplied to sum up to the infinite term. So this will be equals to 1 squared. Added to, we have 2 squared minus 1 squared times x. Added to 3 squared minus 2 squared times x squared. Added to 4 squared minus 3 squared times x cubed, and this is going to continue. So now we have 1 minus x multiplied to s infinity, so this will be equals to, we have 1 added to, so 2 squared, that's 4 minus 1, that's going to give us 3. We have 3x added to 3 squared minus 2 squared, that means we have 9 minus 4, so that's 5. We have 5x squared added to 4 squared, that's 16 minus 9, so that's going to give us 7. We have 7x cubed. So we can see a trend here. So once we perform the subtraction, what we get here, so this particular series, so let's call it S prime infinity. So this new series that we obtained, now this is an arithmetico-geometric series. Now that we have an arithmetico-geometric series, so let's name this as number 3. We're going to work from here. So what we'll do, we will take this new sum and we're going to multiply it with the common ratio of the geometric sequence which forms the arithmetico-geometric series. That means here, if we consider 1 as the first term, followed by x, the variable x from the second term, x squared taken from the third term, then we have x cubed from the fourth term. So this is going to be in geometric progression with common ratio r given by x. So we're going to take this x value and we're going to multiply each terms of 3 with x. So that means we have x multiplied to 1 minus x times s up to infinite number of terms. So 1 times x, that's going to be simply x added to 3 times x, that gives us 3x squared. Then 5x squared times x gives us 5x cubed. So this is going to continue. Now we have to perform a subtraction. So let this be number 4. So now what we'll do? Now we'll do 3 minus 4. Now when we do 3 minus 4, we have 1 minus x multiplied to sum up to the infinite terms minus x times 1 minus x times sum up to infinite terms. So that will be equals to, we have the first term as 1. Next term will be 3x minus x, so that gives us 2x added to 5x squared minus 3x squared, so that's 2x squared added to 7x cubed minus 5x cubed, so that's 2x cubed. So this is going to continue. Now on the left hand side, we can take 1 minus x as the common factor. We're also going to take s up to infinite terms as the common factor. So that means it will get multiplied to 1 minus x. That will be equals to 1 added to. Now, if we consider the series, excluding the first term, this particular series is a geometric series. This is an infinite geometric series where the first term a, so that's 2x, the common ratio r, so that's x We can take any term and divide it by the previous term to get the common ratio as x. And we know the sum to infinite terms of a geometric series that's defined as a over 1 minus r. Now that means in our case we have the first term 2x divided by 1 minus the common ratio, that's x. So we have as our sum of the infinite terms multiplied to 1 minus x whole squared. This will be equals to, we can combine these two terms, we have 1 minus x. So in the numerator we have 1 minus x added to 2x, that gives us 1 plus x. So finally we can obtain the sum up to the infinite terms. Now this is going to give us 1 plus x whole divided by 1 minus x whole cube. So this is going to be the sum to infinite terms of the given series 1 squared plus 2 squared times x plus 3 squared times x squared plus 4 squared times x cubed and so on.